Okay, Gary. So over to you. Thanks very much.
Righto. Well, when we talk about adaptations, we tend to think about anything that might help the survival of a plant or animal, and they can be structural and physiological or functional. But we pose the question tonight, what of extreme stressors from climate change, for example, will the plant still be climate change and fire resistant if there are really big fires and really big changes in climate. So next, Ian. For example, back in 1994, we had what you could only describe as one of the biggest mega fires we've ever had in Royal National Park. 95% of Royal National Park was burnt. Um, Often we talk about the bush bouncing back after such fires, but this fire was that big that the black butts in the tall open forest, for example, had lots of hollows in them that greater gliders used to live in, and those trees with those hollows were destroyed. So even the habitat produced by fire was destroyed by a fire of this scale. And we basically have impacts such as local extinction of these greater gliders. I think one has been seen in the
Yeah.
30 years since, one or two, that's about it. And our branch of NPA is actually working a lot trying to keep connectivity between the open forest of Royal National Park and the Illawarra Escarpment because we need to recolonise an area after such an impact. So um, in some cases, of course, rainforest does not have the adaptations that dry sclerophyll forest and heath has to fire. So there can be permanent changes when you get fires this big. Next, thanks.
Just before you go on, Gary, I'd just like to ask, it's interesting here you see the photo looking towards the national park from the south end. This is pretty much from the Otford Pie Shop.
That's right. Yeah,
And we can see the headlands of North Gary there and semi-detached point, that sort of crocodile-shaped protuberance of rock there coming out from the vegetation. Uh, what's the story behind this? You were actually there and could go no further, I guess. What's the story for the photograph?
yes. Alternative routes to get around Royal in that particular case.
Right, yeah.
Anyway, I'll plug on
Yep.
the next one. And when we start looking at what fires can do, we often think, oh, it adds extra carbon dioxide to the atmosphere, for sure. But also, if the fire is big enough, the amount of carbon that is tied up in living plants is actually reduced even more enormously as you get more and more of the living tissue burnt beneath the bark. So it's biodiversity impacts as much as impacts on increased carbon dioxide in the atmosphere. Next, thanks. And it was news, of course. 95% of the Royal was burnt. Major backburns were done to try to save waterfall, well, to guard against possible wind changes. We and several of us within NPA were actually called into the superintendent's office after the fire, basically saying we had to do this. We had to burn even more than it was naturally burning because there was a real risk of a wind change. So it's big news, and the question is, when they're that big, to what extent will they recover? Next, thanks. Now, when you go to the fire ground after a fire, you see things like this. Banksia seed pods opened up. And the interesting thing here is that the outside seems to have been burnt, but not the inside. And we often talk about fire opening up the seed pods and releasing the seeds and everything carrying on in the next generation as the seeds fly away. The trouble is, would you not think that the inside would also be burnt as soon as they opened, as soon as these seed pods opened up. But what actually happens is that um, there is a delay in the opening because what happens is that there's a valve on each of these containers for these seeds that gradually dehydrates, and it acts through the osmotic pressure that is created to open up the seed pods some short time after the main fire front has gone through. So in fact you have viable seeds that are still living, ready to be released after the major part of the fire front has gone through. So it's quite an interesting adaptation, that it's this physiological cellular level adaptation that enables plants such as this that have hard seed pods to survive despite the scale of the fire. Well, we think that they'll be able to be adapted to very large fires, but perhaps if they're really big, the impact of the heat could go through to the actual viable seed before the pod even opens. So they're questions that have been untested by experimentation. Next, thanks. And what has happened here? We've got a seed pod with open seeds, and we've got a flower. Um, so one possibility here is that the seed pod is opened um, after uh, after it had flowered, the original seed pod, just through sheer heat of the environment, as opposed to heat from a fire. And in another part of the shrub, there is a viable flower being produced next to a seed pod. Whoops, slow down, Ian.
Yeah, you said next, sorry.
Next to a seed pod that has opened by a mechanism other than by fire. But fire is certainly the major trigger for opening these. Next. And when I actually got, at the time, I was working at TAFE, uh, and I got a paid gig through National Parks and Wildlife Service to go around and review the damage, particularly to tracks. And I was one of the first people to be allowed to walk through the fire ground, but as well as noticing degree of track infrastructure damage. Had a bit of a look at the regeneration. And of course, the grass trees were one of the first to come up, one of the first colonisers. And maybe, well, very possibly the reason that they are one of the first to come up is that the base of the living leaf tissue is well protected by clumps of itself. And also there's resin, which is usually a fuel, but if the resin bits are thick enough, it might actually form an insulating layer as well to give the grass trees a bit of protection. Next. And here it demonstrates just what is the nature of this surrounding envelope of insulation. We selectively took out, and I had a school group at one stage, selectively took out some grass tree stems. This wasn't related to the fire, but it shows that there's carbohydrate layers that form the emergency energy package that allows these grass trees to regenerate amongst the first plants to do so. So yeah, there is actually an edible base. They're not eating the top of the leaves there, they're eating the base of a couple of leaves. So at least some carbon can be saved for the next generation to propagate. Next. And then the other thing that happens with grass trees after fire is they often flower within a year, of the fire. So you can see the fire impacts in the background with the small banksias that are pretty much dead. And yet the grass trees are thriving. There's a few grasses starting to appear now because they've got underground stems that are protected by soil as much as anything else. So Yeah, and the other thing that's the next one, thanks, Ian. And the other thing that happens is that you start to get the flowers coming up within the year, which attracts honey-eating birds, which causes cross-pollination, blah, blah, blah. And so you you have the whole ecosystem or different elements of it, animals and plants, starting to regenerate at the same time and very rapidly after fire. So it's always good to see what else comes up fairly quickly. Next, thanks, including the animals. And there's a bit of proof that the flowers have nectar on them. You know, she was saying, oh, it tastes sweet. So, and ironically, she's got an apple there, which has a big carbohydrate store, as do the seeds that will be produced that will form food for other types of birds besides the honey eaters, namely the seed eaters. Um, so this is all happening extremely rapidly. So we shouldn't just look at a single adaptation and hypothesize, oh, that is the thing. No, you might be setting in train a whole new uh, ecological change and regeneration through one or two adaptations that, if you like, step on the previous one. Oops, sorry, I was going to change that myself. Thanks, Dan. Okay, so one of the most common adaptations to fire that is often quoted for some groups of eucalypts, such as the bloodwoods or corymbia, is the thick insulating bark. And this particular species has friable bark. So in amongst the bark are a lot of air spaces, and air is actually a good insulator. So just saying that it's got thick, friable, insulating bark to reduce the impact of fire on buds beneath the bark is one way of expressing what that adaptation is about. So you describe the physical thing, and the degree of the change. So it's thick bark, and it is used for a function to protect the the underbark buds from drying out when there is a major environmental stressor, such as a fire. So that's a complete story of how you would describe an adaptation. And as long as your hypothesis for how you describe that adaptation sounds reasonable, it's a teacher, educationally, you'll always get it ticked right, but it's not necessarily true. I mean, there might be some other reason why there's friable bark on the corymbia. So not a large number of adaptations have actually been studied scientifically, but I'm integrating into this talk several results of actual experimentation that have put the finger on exactly what the adaptation is, because sometimes your intuition is not necessarily right as to what is the main sort of feature of that adaptation. Oops, next Dan. Now this is one of the most interesting lot of adaptations that are seen in uh, dry sclerophyll forest in particular, particularly with larger trees like eucalypts and whatever. You have what is known as epicormic buds, not far beneath the bark. And when these buds come up, when they germinate, what actually happens is that there is a hormone in the tips of the branches and the tips of the former leaves before they get burnt. There's a hormone that gets sent down through all of the trees' phloem tubes, if you like, that actually sends a hormonal message to these epicormic or underbark buds that tells them not to germinate. So when the fire destroys the tips and the other thick parts of the other parts of the foliage, what happens is that hormone that normally stops the budding of the epicormic buds actually stops working and allows the allows the epicormic bud to actually blossom the way you see here. So this is its natural position, to be like that, but it's stopped from being like that by negative feedback loop the from the live leaves. And this anthocyanin pigment, the leaves are at a very vulnerable stage here. There's stressors happening. There's smaller leaves. They've been under, the bud that produced them has been under stress. And the anthocyanin, this stage of the leaf cycle, actually absorbs um, green and green and blue light and allows red to transmit. So it's green and blue that allow the photosynthesis to happen, and the reddy and the purpley colour is the one that shines through, as opposed to more mature leaves that are green, where the red and where the red light is absorbed and the green is transmitted in the photosynthetic process. And this is the same purple anthocyanin that appears in deciduous leaves when the northern hemisphere trees become deciduous and drop their leaves. It often is this transition from green to purple or red before they drop. And the other thing that anthocyanin seems to do, from some experimental evidence, is that it it acts as a antioxidant, so that while the leaf is in a vulnerable state, um, radicals that might be active and destroy cells, like cancerous type things is the equivalent in cancers, that these antioxidants actually stop the leaf from being attacked. Um, and so life can go on. Okay, next one. Thanks, Ian. Okay, if we start looking at other things that allow plants to grow in the environment, you need to have access to water. So, for example, the Hawkesbury sandstone, even though it's an extremely dry situation with the water that drains pretty readily, um, large shrubs and smaller trees can actually get the roots down through these joint planes as the Hawkesbury sandstone has contracted as it solidifies from the original sandy sediments. And see down the bottom of the slide, there's still iron around. That could be surface, but you often have a mixture of ions and silica. Well, silica, of course, is the main thing. And yeah, so those cracks might also help leaching of the minerals away from a very poor fertility soil, which adds an additional stressor that the plants have to deal with in heathland areas, for example. Next. And here we see the classic example of Hawkesbury sandstone, where every mineral except silica has pretty much been removed over the millennia. So plants that are heath in this sort of environment, they really need to have tricky adaptations to deal with that sort of stressor, because you can't have no nutrients to allow plants to grow. I think that was taken before the fence was put up down at Wedding Cake Rock. Next thing, Sam. And if we look generally over the coastline of Royal National Park, you'll see that it's very thin soil that can support very low shrubs that are hit by the stressors of not just lack of water and lack of soil and nutrients, but dehydrating effects of salt spray. So that's why you do have very low growing heath type plants where the wind impact and evaporative impact is decreased. And the fact that the top of the sandstone is usually pretty uneven means that there's little wells where any nutrient formed by the decomposition of some initial plant colonisers can actually accumulate in these places and allow slightly bigger and bigger vegetation to grow. But certainly limited nutrients is one of the biggest stressors that it has to deal with here. Next. As opposed to going down into the gullies, into the southern part of Lady Carrington Drive, where the Narrabeen Shale outcrops, produces a far thicker and more nutritious soil. And even though these plants don't have epicormic buds as a adaptation to fire and extreme heat situations, you can get much bigger trees growing due to the increased nutrient levels and the increased water absorbing characteristics of soil formed by the breakdown of shale, which has very fine grains, as opposed to, we often think of sands as fine grains, but the shale produces much finer grains, the muddy type stuff that really holds the moisture in much better. So they usually don't need the adaptations of fire resistance, because it's classically over millions of years, these environments have been fairly moist, and you don't need those sort of adaptations, but that could well be changing. We now increasingly see fires that get into this sort of environment and can permanently remove vegetation that doesn't have the adaptations that have been evolved over millions of years. Thanks, Ian. Okay, we come to the heathland, and that classic adaptations here include small pungent leaves. Pungent meaning, very prickly, hence Acacia ulicifolia, meaning needle-shaped leaves. So, yeah, the needle-shaped leaves and the small sharp leaves are an adaptation to reduce herbivorous grazing, but the shape of the leaves, the very thin nature of them, means that there is a much smaller surface area to volume ratio than in conventional big flat leaves. So there is less transpiration, in other words. Less surface area to volume ratio means less loss of moisture from the leaves. So things like the prickly moses can actually resist drying out much better than if they had another shaped leaf. And the pollen from the flowers, a lot of people think that when the wattle is flowering, that's a time when you get all your sniffles and whatever. But apparently the pollen from things like wattles is much heavier than the pollen from native grasses, for example. So it's thought that those big bouts of hay fever and even worse conditions that can strike a whole area is due to the great mass of grass seeds that is floating around in the atmosphere, being blown around. Next. And another common adaptation that's often quoted is hard seed pods in heathland and dry sclerophyll forest. This is Hakea sericea, and the classic snail-shaped seed pod. And you can see the swelling on the base of the snail-like seed pod. The bigger that base is, the deeper is are the seeds embedded to give them greater protection from fire. Next. And this one is your classic woody covering on the seeds and the woody pear or xylomemum, which you do see periodically in different parts of Royal National Park, for example. Next. And drumsticks and cone sticks. looks nice and furry, and soft, with the flower. But then it soon, as they lose uh, their flower parts, the seed pod gets bigger and bigger as the seeds develop inside, and more protective from things such as fire. Next. All right, let's come to the eucalypts and have a closer look at them. I love taking pictures of translucent leaves, gum leaves, the backlit and whatever, but look at it from the point of view of the leaves trying, in inverted commas, to survive in a desiccating environment. Couple of things here. You have, with the leaves being translucent, the light energy, the red and orange pigments that get absorbed by chlorophyll can do their job and produce carbohydrates or starches, but the heat part, the infrared part of the spectrum, can go straight through leaves that are transparent. So in other words, it decreases the amount of heat that is absorbed by the leaf, and hence reduces the amount of transpiration that or water that can be released by the leaf under dehydrating conditions. So having a transparent leaf is sometimes pretty useful. And if they're not transparent, we'll come to other adaptations if they're not transparent. And you can see some of those early leaves have that light orange to yellow colour, as that anthocyanin is the dominant pigment. The other thing you may be able to see on this leaf, there are pores in the leaf, and they're oil glands. There's two types of oil glands that's been discovered. One is to produce toxins that discourage herbivores from eating the leaves, apart from things like koalas and some possums that are adapted to neutralizing the effect of those toxins in the oil glands. But there's another type of oil gland that is not as clear, which which isolates the waste produced by the metabolism of the plant. So yeah, so we now know that there's differentiation of functions between different oil glands. It was always a bit of a mystery as to why eucalypts had oil glands. They seem to be something that might have just encouraged hotter fires, but it does have a couple of real survival functions. Next. And here's another type of plant that you tend to get down into the wet areas, but it still might be pretty hot. So the dog rose or Barrier reboides still has very translucent cells in the petals. They're only a couple of cells thick to allow the heat to pass through and not to get absorbed, and hence adding yet another environmental stress. Next. And if in fact your leaves are not as translucent as that one eucalypt I did show you, and that stops the heat from building up, another adaptation that they've got is even if the leaves heat up, if they've got a waxy coating, you can decrease the transpiration from that leaf. So that's another adaptation that's quite common in dry sclerophyll forests, a waxy leaf. You can see that it's waxy by the way the drops are sort of forming little circular bits there with the surface tension. And once again, there's our anthocyanin friend in the new leaves. Next, thanks. And another way to stay cool is to have drooping leaves, and most most books and texts and whatever quote the fact that they way um, they move about in the wind, and that is a bit like you're washing on the line and being cooled down by winds that move the clothes around. Now, whether that's just a good hypothesis, it sounds reasonable, but to what extent has there been any real study done on that? I don't know. I'm not too sure about that one. Next. Okay. This bark is particularly, it's been sacrificial in a fairly hot fire. There seems to be some leaves coming up. It's a bit hard to tell what species I photographed here, but they could be little buds coming up from beneath the soil from lignotubers or underground stems, whereas above it, there doesn't seem to be any, for that section anyway, they don't seem to be too many epicormic buds that have survived. And it's now known that when a fire comes through a dry sclerophyll forest like this, the epicormic buds that are on the thinnest branches and down to the medium-sized branches are pretty much destroyed. So you might only get about 50% of epicormic buds actually budding after a fire because it depends on how deeply protected they are. But when it comes down to a lignotuber, it's like an extension of the stem. The lignotuber can have up to 70 to 80% of buds that actually that blossom out because they're protected not just by the bark but by the soil. So you've got a double protection there for to help ensure the next generation survives. Next, thanks. And you the bark gets drier, um, starts to peel off, becomes less valuable as an insulator as the tree ages, so the bark peels off. Now it doesn't just peel off, of course, make a make a better fire-resistant regime. It also peels off to allow the trunk to grow. So that's why most eucalypts seem to shed their bark. Yeah, next. And that's a Angophora costata, smooth-barked apple. Regularly peels the bark I often see it in January, February. But if you look on the surface of the bark, there's little dimples that little spiders live in, and bigger spiders like huntsmen live under the peeling bark. And it's interesting that when rain is forecast, people often talk about those huntsmen coming indoors. And the reason they seem to do that is that in its natural habitat, these spiders have what is known as a thigmotactic response. They like snuggling their body in where they can feel contact with their surroundings on as many surfaces as possible. So when a tree is going to be flooded by rain, they can come down the trunk and head off to your home, find crack just like the ones you see in here, and the ones around loosely fitting windows and the underneaths of doors are ideal. They snuggle in there and think, oh, this is all right. And then some of them might actually get through and crawl up to the ceiling to scare the living daylights out of you. So it doesn't have much to do with adaptations. But look, I mean, one thing where this might be significant, the peeling bark may well be a necessary part of the life cycle of things such as spiders. And if you can imagine the peeling of the bark getting out of sync with the development of spiders and other animals that get protected here, you might get a situation where you get local extinction of species. And there are hundreds of scientific papers looking at impacts like this caused by various sort of serendipitous examples of climate change in action affecting the life cycle of another organism. So we just don't know the full scale of what might happen as these different life cycles get out of sync with one another. Next, thanks. Okay, an adaptation of Angophora costata that every school principal knows about. You don't go putting kids under on Angophoras in the playground because it's well known that during very dry conditions, you have drought deciduous branches that drop down. So it's not the leaves that fall, it's the branches that hold the leaves. When they fall, it puts less stress on losing water through the leaves that have fallen off. But it also creates the actual nature, the interesting appearance of the Angophora. If we can look at the next picture. Yeah, so the growth patterns of sudden angle changes, and you can see the bumps at those junctions, the big bumps. That's quite typical of the sort of scarring that takes place after a branch has fallen off, and the Angophora works to heal the scar. Hence, it leaves all these sort of big knobs all over the tree, and particularly at the junctions where there's been a change in direction of the new part of the branches. And there actually is a couple of sources show an existing Aboriginal story from the Dharawal people and further south, that those branches, those bumps represent the place where Darramullan, the sky hero or sky ancestor, as they're sometimes called, where Darramullan used to sit and look at the behaviour and ceremonies of the tribe down below. So you get these smooth patches. And the other value of those bumps is that they were removed to make coolamans, water carriers and baby carriers and the like. But this is how this tree can survive in very dry conditions. So whether the trees are going to get more branched in the future as more drought periods, extended drought periods cause a stressor, we don't know. But as I said, there's plenty of examples of things of that nature appearing in the literature right now. Next, thanks. And another way to survive a stressor such as a fire, sometimes the seeds are dropped, very small seeds, not necessarily the great big ones that you see in the Banksias. So this is a, what do you call it? Baronian, yeah. So this one was taken in the fire ground of that big 94 fire, only 12 months after the fire. So it's got as opposed to Banksia ericifolia that people classically say takes about 7 years to flower and produce seeds. This one can get the ecosystem moving along a bit quicker because the dormant seeds have been in the ground and they simply germinate once the fire path goes through, and you get a bit of rain to increase the chances of rapid germination. It's a bit like the desert plants, Western Australia and Central Australia, dormancy. Thanks, Ian. And that's a Gymea lily. We had a couple of Gymea lilies at our place at Oatley, and they actually flowered once or twice, but the trick to get them to flower again was to cut off about a quarter of the leaves. It looked a bit cruel, but once again, it's this hormonal effect. The production of flower stalks is halted by the mass of surrounding leaves that are giving out hormones to stop a new flower shoot from going up. So after fire, it does just what some of the eucalypts do. You know, they what were once dormant buds and leaves and whatever, or in this case, flower stalk, suddenly take off while that hormonal influence is not there to stop it from flowering. Next. And I don't know why I call that a guy, me a lily, Ian. I know Ian went over his picture.
Oh, sorry.
Waratah, I'm sorry.
Sorry, Tara. Yeah, sorry.
I must have had a bad
No, no,
day.
no.
But the only reason I put in this lovely Waratah picture, okay, you've got big leaves, which you think would transpire a lot of moisture, but they're leathery leaves. So a lot of species have leathery leaves as opposed to waxy leaves, and that is another adaptation to decreasing water loss. The big red flower, there's Aboriginal legends about these attracting birds. Um, so it's a bird attractant, something with a flower that big, just like your big banksias that attract the different large honey eaters. And the other thing about this family Proteaceae, sometimes you'll find these waratahs spread out in an area of, in the understory of dry sclerophyll forest especially, and there'll be masses of them there. And we now know that one of the things contributing to the health of waratahs is this great network under the soil of what are known as mycorrhizal fungi. Um, this is a fungal net that spreads out over a very large area. And do you call that one individual? Is a question. And what happens is that they form a net that in which there's a symbiotic relationship with the masses of plants, such as the Proteaceae and the Myrtaceae, also carry this do this adaptation well. And what happens is that the waratah photosynthesizes and produces carbohydrates. The fungi that are in this net, this special type of fungus, it absorbs the carbohydrate that is produced by the plants above it, and also more efficiently captures the low nutrient levels like the nitrates and whatever, and water into the web of the fungus, and more efficiently transfers that material, the water and the nutrients, to the roots of the waratahs or any other groups of species that are part of this fungal net. And that particular adaptation and that discovery that this is much more common than people think has been used by the horticulture industry, by the agricultural industry. Whoops.
Now keep going, Gary. I'll fix it up now.
Agricultural industry,
Okay.
and by home gardeners. Uh, one hint in making giving a waratah a chance to grow in your home garden, because from everyone I've spoken to, you get about a 90% death rate from attempts to grow a waratah. But one trick apparently is to grab some bush soil, particularly if it's from an area where waratah might grow, and hence capture some of that mycorrhizal fungi to add to your developing and hopefully flowering waratah. So, yeah, understanding the details of those sort of interactions on a fairly large scale is one thing that just might help industry and be very commercially important. Um, and it's just good science that has to be done to really understand what those adaptations are all about. Next, thanks. Yeah, when you get to walk through the heath, there's a massively big biodiversity, and this big biodiversity of heath plants is particularly noticeable in places like the Hawkesbury sandstone areas of the east coast of Australia, around Sydney, Newcastle, south, Blue Mountains, etc. Over in Western Australia, the southwest, and on similar sort of land in South Africa, for example, where the proteas grow profusely in this sort of environment. And Tim Flannery, in one of his books, I just forget which one, but he's got a hypothesis as to why these heathlands are so diverse in species, and he just believes that in environments like this, where the nutrient level is so minusculely low, that any adaptation at all that increases the chances of nutrients or water being absorbed uh, more efficiently will give it a selective advantage over other other genetic variants of that species. And that is the sort of thing that can drive speciation or the expansion of species from the number that we started off with. So of hundreds of species here, Flannery just reckons it's the driver of competition between individuals that are basically trying, in inverted commas, to outdo each other with an ability to absorb the nutrients more efficiently. Next, thanks. All right, come back to the grass tree again, another adaptation that this plant has. It's actually got, if you rub your hands along some of those leaves, you may well cut yourself because uh, there is silica deposited in those leaves. And the mechanism for that, a lot of people think silicon dioxide or sand, which is what you typically get on these really low nutrient areas. They think that the silica is very slightly soluble, infinitesimally soluble, but through the process of what is called active transport in the cells of the roots, you could increase the chances of that low level of dissolved silicon dioxide getting into the plants. It needs a tremendous intake of energy, but the silica gets absorbed into the xylem of this plant, and then it gets deposited on the surface of the leaves. Why? Well, one classic hypothesis is that is to decrease the herbivorous impact. So yeah, so that's soluble sand maybe being used to decrease herbivorous grazing. Next, thanks. And we come to burrowings that you see periodically in different places at Royal National Park. Captain Phillip's men found the seed pods of these over at near La Perouse, and they knew the Aborigines were eating them, but they didn't quite see how they prepared it. You know, they roasted them and they ran them through water. They leached out toxins that are in those red fruits. But a couple of Phillips men got quite ill because they didn't understand what the treatment methods. But the other reason I'll put in the burrowang, show the next. Have I got another picture of a burrowang, Ian?
No, no,
Go back again. Sorry.
that's fine.
Yeah, go back. Yeah. They're really sharp leaves. So a lot of people call these dinosaur plants. So you imagine a dinosaur trying to get into the middle of that plant where the red fruit is well protected, and they'll end up piercing their nose and whatever. Maybe that's why dinosaurs have armor, you know, to get into these sorts of things. So it's sort of coevolution, you know, and I've seen this in the Galapagos, you know, the tortoises evolve bigger necks and the trees get bigger and bigger and they just follow each other. And maybe this is the same sort of thing. The leaves get sharper and sharper the more the dinosaurs try to get to the fruit in the middle. And so now you're taking your life into your hands if you try to put your hand inside a very big, well-protected burrowang. Next. Okay, and the picture on the left, I just wanted to demonstrate a mallee type growth. That may well be the one scribbly gum, that one there. And one adaptation that if you go through Royal National Park, you'll see a number of different species, including the so-named Port Jackson mallee, that has that mallee growth habit as if you're in Central Australia somewhere or down at Lake Mungo. Um, and the theory with this is that in order for these moderate sized trees to get water to the upper leaves, it's far more efficient from an energy point of view to split the trunk up into three or four or more, like dozens of branches, if you like, coming from a common base, and taking the water up a smaller height, as opposed to having a really tall tree where the energy to go beyond 10, 20, 30 metres is just too much to efficiently absorb water. So the mallee growth habit may well help with absorption of water in dry conditions where the water availability is pretty low. And on the right, we've got a scribbly gum, and it's been eroded away at the base quite a bit. And I think you could say that that big base is probably an exposed lignotuber. It really is just part of the stem, and sort of illustrates that fairly well. Next, thanks. Yeah, and I mentioned the story of how the spider life cycles and the peeling of bark might have got out of sync. Here's another um, made up hypothesis as to what might happen to scribbly gums in the future under a regime of climate change. So you have a scribbly gum moth. Can you see my cursor pointing up there, folks?
Not particularly.
Oh, you can't. Oh, well,
Well, I can't anyway.
I'm just entertaining myself. Anyway, up the top with a very thin scribble. There, that's the point. You've got this. You've got
Yep.
it again. Yeah. Um, so the scribbly gum moth lays an egg beneath the bark that used to be here, right? So we're seeing it after the bark is peeled away, and then follow that down in until it gets to a thicker part. More, round we go. Keep going, round we go. Now see how it gets thicker there, right? So what's happened is that the larva has stopped and shed its exoskeleton, then grown another one and has grown wider before it goes on its journey again. You can take the journey down to the end if you like. And down there you go. All right. Now down at that point, it pupates. And just at the time it pupates, the bark should be starting to shed so that the pupa can drop in a bed of leaves and whatever dead leaves and whatever at the base of the tree to enable it to develop into an adult scribbly gum in favourable environments, where it's protected from predators and the whole bit. However, think of the scenario where the bark, the you, you see all the bark being shed off scribbly gums and other trees, where the bark gets shed before the pupa has formed. It might be, show it halfway down on that journey, yeah? Yeah, let's say it only gets down that far, or even lower. No, down further, down further. Yeah, let's say it only gets that far. Well, when the bark peels away, the tree creeper bird might just be crawling up that trunk and grabs the larva before it has a chance to pupate. Now, as I said, there are more tales like that in the naked city with the uh, literature on just all the little things that are getting out of sync with climate change. Hundreds of them, hundreds, probably thousands. So I just quote that. I used to quote this one to my students when I worked down at Royal National Park, almost before people started talking about climate change. As soon as um, I just used an example like that to try to educate students that things can go wrong if you get things out of sync, if you don't allow the normal patterns that have evolved over millennia to happen. I know one other thing I wanted to say. I forgot to mention it when we were looking at the picture of that anthocyanin-rich uh, sprouting of eucalyptus leaves. That sprouting that
Pardon me,
is part of.
Gary.
Oh,
I,
no, don't bother trying to find it, Ian. I'll just mention it. That sprouting is part of the normal cycle of plants being burnt and then regeneration, right? For hormones being switched on and off, and creating a cycle of making sure that the next generation survives. But we now know through genetic studies of fossils that that process of producing epicormic buds and putting an inbuilt protection into a fire regime started about 60 million years ago with the eucalypts and those sort of families of plants. And it's all to do with the northward movement of the part of Gondwana that Australia is in. So move north, gets hotter and hotter, hotter and hotter. The epicormic buds start developing in response to um, that evolving stressor related to the movement of continents. And that's where it all comes from. So the plants that were protected in gullies that didn't normally have fire, they didn't develop that adaptation. But it's about a 60 million year old adaptation, we now know from interesting research. So genetic research is uncovering all sorts of, solving all sorts of mysteries for us. Next, thanks, Ian. But it's not just the plant directly being affected that might lead to changes in ecosystems in the future. This is the fire ground. Once again, a few months after the big '94 fire, and what we see here is water that has run off into a perched dune and has eroded away uh, down to about 30 or 40 centimetres. So, that net of fungi that might have been there is disturbed. Um, Plants are washed away. Uh, Diversity is less. Uh, the erosion can expand a lot more. So that is another way that just through weather changes and physical water movements might impact on ecosystems in the future, not just through the organisms not quite having the adaptation to cope with certain stressors. Next. And that's a runnel being created after that rain, which cumulatively can add to the potential impacts on our ecosystems of this nature. Next. Oh, don't worry about that. We've talked about the wattle quite a bit. And just to finish off, probably you've heard about the net of fungi that help to get sparse nutrients of nitrogen um, into the plants from existing nitrates that are in the soil, very low quantities. But what if you've got no nitrates in the soil? It's next to zero. Well, if you get um, things like that wattle that you saw before, the sweet-scented wattle and many other sorts of wattle, for example, and dig down to the roots, you'll find that they've got all these nodules. And these plants can indeed cope with almost zero nitrogen because what these have got is bacteria in the nodules. They're nitrogen-fixing nodules that transfer the the nitrogen in the air and in the spaces in the soil into nitrates. So farmers, of course, know about this when they sow clover and the like. But as far as our ecosystem protections are concerned, it just might be organisms such as these that have smart mechanisms to actually create nitrates and nutrients from the nitrogen in the air that could be the saviour of some of our ecosystems. So that's where it all ends, folks. We just hope on a high note. Thank you.
Thanks very much, Gary. I invite anyone that's got a question to ask a question.
And unshare the screen, Ian.
Yeah, unshare it. What a good idea. I'll
So
stop.
we can actually see faces, sort of.
Is that better?
Yeah.
I don't know, just yeah. Um, yeah. So
Any questions, folks? Not that I'm an expert. If in doubt, I hypothesize. That's what we scientists do.
That's a demanding question.
it's such a comprehensive delivery, Gary, that you've answered all the questions. Or maybe Lydia's got something from
She
Lydia.
has a question there. Lydia, you can actually ask her personally, you know, dear.
Hi, Lydia.
Where's Lydia?
She's coming on now.
I'm mute. Hello, everyone.
Where's your picture?
Oh, where's the picture? Oh, here.
Video.
There
Oh,
you are.
look who's there.
Hi. I just wanted to ask
Colin.
a question in regards to the stress of industrial age contamination
Yeah,
to
what
the
about?
plants. Is there any current studies on that? And also, when we were doing the native planting in those kind of environment with those stresses, what we should keep in mind, for example, should we be planting with more focus on flora preservation rather than flora restoration, or they have to go hand in hand?
I think, use whatever information you've got to
Yeah.
plant in groups, the interdependence of plants and fungi and all that sort of thing.
Mm.
I mean, agricultural scientists and horticulturalists are going into this sort of stuff in a big way. So it's good if the scientists who are amongst you can give some insights into that. Like I mentioned, the idea of
The
just getting
wattle.
some bush soil to grow
Yeah.
potato. I know there's not a similar thing there,
Yeah.
but I don't have much detailed knowledge of that area, Lydia, I'm afraid.
Okay. Because I try to learn a little bit more, and I sort of get it from bits and pieces. And I heard that, like you said, wattle is good. It's like a pioneer plant.
Good pioneer plant,
Yeah,
yep.
that is to help with the nutrient.
Makes its
And
own nitrogen. Yep.
yes, that's
Yep.
right, the nitrogen fixer. And the other one that I heard is the Pomodorus. I heard it is a good plant to be planted in disturbed soils. But
Pomodoros would work quite well like that, Lydia. Yeah.
okay, yeah.
Yeah.
So I thought, if there's any studies or any books about that, I
Well,
would
think
be
of
keen to read.
Yeah.
think of
The
the
trouble with Pomodoros is there are so many species that I can never tell them apart, and neither can the experts, I'm told.
Is that right?
Botanists tell me they never try to separate Pomodoros from.
Yeah. I just go to Sutherland Community Nursery with a Dark's book, plant list, and I said, "Can I get this Pomodoros and that Pomodoro?" And they gave it to me, and I plant them.
Louis, have you got any expertise on this?
No, not really. Sorry.
Oh,
well, we're in the same team here.
was trying.
Yeah, nice try. Yeah.
Yeah, nice try.
Anyway, Google it, Lydia.
Okay, all right. I
Righto.
shall.
Ask Doug Benson.
Yeah, that's
Yeah,
right.
I will. He is helping me. Yes.
Yeah.
Well, there
Ian,
you
you
go.
know Lydia is one
Halfway
of the
there.
world's great networkers, don't you?
Oh,
She's already got Doug Benson on call.
100%,
But he's a good teacher. He's a good teacher. He's a really good teacher.
Yeah.
And and he never forced me to learn, but I never missed the session. I had to apply for sick leave whenever I'm not there.
Okay.
He's teaching you to ask better questions, which are putting us all under stress.
Oh
Yeah.
no, I don't want to be your stressor.
Yeah.
Anyway,
It's
thank
Helen
you.
here. I'd just like to comment how quickly the Royal National Park rejuvenated after the 94 fires.
Mm.
I mean, if you
Yes.
didn't know what had happened,
Well,
we'd be surprised.
Yeah.
no, well, certainly on the surface, it gets green very rapidly. But if you're wandering like along the Wallamurra track, for example, and a big fire has been through a year or two ago, you'll see one or two species dominating. So it's the dynamic nature of the interactions that are there and the species that have disappeared. You know, there's decreased. You keep having one big fire after the other, and the diversity would go down enormously, and a lot of people would still think, oh, it's good to see it's green. So you've got to be careful that you're not just looking at it from a peripheral.
Helen, of course, was on the Wallamurra track on Monday.
Indeed, I was.
Mhm. Yeah.
Actually, if you can put your video on, Helen, we'll know what you look like.
Not a chance. I got my pajamas on.
Oh, we wanted to see what color they were.
So have I, Helen.
The pajama festival.
Yeah.
Well, I was on it on Saturday, but Monday it rained, didn't it? I think, right?
It rained on us, yes.
Mm.
But yeah, a very diverse collection of plants, as per what Gary suggested.
Did you get to the Ampiera down on the rock face?
No, it started to rain before that, and I had to get back in time to receive my phone call for when to go to the doctors
So on
to
the
hospital today.
in the scrubland and woodland after that sharp bend to the left, how far along there did you get?
Oh, quite a distance beyond that.
Okay.
We're only about 10 minutes walking time from the end of the track,
Okay.
believe it or not.
You see the Grevillea oleoides?
Of course.
Yeah. Oh, that's good. Okay. Just checking you saw it.
Yeah.
And the Tetratheca?
I
in the
didn't,
corner?
but it was photographed by one of my party, Elaine, and I haven't told her this, but I'm actually contemplating inviting Elaine to run. For those of you who have not met Elaine Yo, she is a photographer who only uses a mobile phone.
Yeah, it's good, isn't it?
But she's actually winning competitions with the photography, and I'm going to get her to do an entire session on how to take photographs with a mobile where she can demonstrate it.
Just before you got to that
would be
sharp
great.
left-hand corner when you came down the Sedgeland Heath, on the left-hand side, on the southern side, that's where the Tetratheca was this time, quite an abundant.
Yeah, look, there's a very good chance that the one-eyed Everingham missed it.
Yeah.
I miss a lot at the moment.
Well, you had two eyes at that stage.
Yeah, but one of them was fuzzy.
Okay. All right.
Other questions of Gary, Ian?
Well, Gary did a very good job today.
Indeed, he did.
I liked a lot of your anecdotes, Gary, and talk about the anthocyanin and things. There were factors there that I'd never heard, so I was really interested.
Gary, there was a Australian Growing Plants article on that anthocyanin, and it spoke about that as providing protection from sunburn for the plant.
Oh, right. Yeah.
Have you
I haven't seen that one. No.
Okay.
Actually, a question, but having that word
Oh, that
cyanin,
might have something to do with the antioxidants that I talked about.
was the
Yeah.
cyanin referring to the color?
Anthocyanin is the name of the pigment. Yeah.
Okay. And I was just wondering whether it was linked to cyanide, but okay. Yeah, cyan, the color.
Yeah. Okay.
I've learned a lot tonight, Gary. I had always thought that the Angophora was just demonstrating its intelligence by avoiding being cut by tree collectors, by humans who wanted to turn it into timber. And that's why they turn themselves inside out and knotty. Now you've disappointed me altogether that it's actually a totally different story. But
Well, that's my hypothesis anyway, and other people have said the same.
Actually, I could ask Gary a question. Gary, with scribbly bark gum trees, Hemistoma, etc. They don't particularly shed their bark like Angophoras, yet they're smooth bark. Have you got a hypothesis as to the fire advantage of a smooth bark? And for example, I'm just thinking about
Yes,
blackbutts.
I,
Blackbutts up the top, they decort their bark.
I think it might be reflecting heat.
Yeah, I was thinking.
The pure,
They're white.
like the ghost gums, aren't they?
Yeah, white
in Central Australia.
Oh, look who's just moved in.
No, John's been here the whole time.
Has
He's
he?
just put the screen on.
Oh, sorry, John.
Gary, I actually do have a serious question as distinct from the tree one. The fact that so many eucalypts drop their bark in summer and thereby increasing the litter has been postulated by some people that eucalyptus trees, which like fire, are using fire as a weapon to beat back other ecosystems that are not fire resistant. Have you heard that theory?
No, I've never got inside the mind of a scribbly gum, I'm afraid.
It has been put forward by serious botanists, that one.
Yeah, no, I haven't heard that one. It's all possible, I suppose.
It's interesting that they drop it in, a lot of them drop it in summer at the most flammable time.
Yeah. Okay.
I'm currently looking for huntsmans in my room.
No, I hope I didn't give you nightmares.
Good luck, Helen. They are so cute.
Just seal your underneath your door and windows and chimney and everything.
Wait till you get in your bed.
You'll be right.
In between the sheets in your bed.
Oh, thanks for that.
All right.
That's a good word, thigmotactic.
Yeah, Gary, you came up with words tonight. Never heard of them before. So thank you so much.
That's the problem with being a biologist. You accumulate some of those over the years.
No, wonderful.
Okay.
John, you're the John Pratt. You weren't here, I don't think, for the AGM, were you? Can't hear you.
You're on mute, John.
Still on mute.
Can I turn this up?
Yeah, turn it up, love. Yeah, look, I better be leaving soon, folks.
Yeah, I was just saying that Johnny's been elected as our social secretary in the AGM again.
He'll get the note.
Yeah.
Thank you. I'll need to close too. I've got a very early appointment to have this thing taken off.
Okay, well, look, Gary, thanks for a wonderful presentation. It was, just so deep in knowledge and beautifully presented at a lovely pace. It was the photographs were excellent. Thank you very much for that. I hope everyone enjoyed it as much as I did. Is that claps from Helen? So thank you, Helen, and Ross and others. And we wish Brian all the best with his recovery. And we wish Ross has a happy holiday for the next number of weeks. I won't mention how long you're going to be away. But
is that a wildflower trip?
It is. It is. Yes.
Yeah. Wow.
Over to Western Australia.
That's great. I'm going in September.
Well, he'll still be there.
You didn't want to borrow my orchid book, did you, Ross?
I've got one.
It's 2 volumes.
Oh, no.
Look forward to seeing your pictures, Ross.
Yeah.
Cheers.
You might be good for a talk.
Yeah, well, Ross and Lydia together will be putting on a Wildflowers of Western Australia trip on their return.
Oh,
Thank you very much.
No pressure.
All right. Pressure.
Okay, well, thank you one and all.
Good night, folks.
And good night.
Thank you, Barry.
And it's
Thank
been
you very
recorded,
much.
so
Thank you, Gary. Thank you, Brian.
Thanks,
thank you.
Ian,
Thanks, folks.
Stop recording.
Ross.
Thank you.
Bye.